So good afternoon, good night, good morning. I don't know what to say. It's around 12 right now. So this is Rohit, Integrated MTech Business Analytics course. So thank you for giving me this opportunity, sir, for doing these kind of project presentations. So I hope we meet you soon in the next semesters or the next coming subjects. So now we are in third year right now, third year first semester. So happy Diwali again, sir. Today is Diwali, I guess. Happy Diwali, sir. So today I've chose my topic zero knowledge proof privacy preserving digital identity verification topic. Why I chose this topic? So I'll be explaining in the next now upcoming slides. So basically, what is zero knowledge proofs? So zero knowledge proofs are nothing but in this digital world privacy, it has become concern. We need to share our personal details like our ID, address, or age to prove who we are without sharing our private details. So exactly that's why we have chosen the zero knowledge proof. So this is a cryptographic method that helps to prove someone without any secret of us. So that is called the zero knowledge proof. So what are zero knowledge proofs? So zero knowledge proofs is nothing but it's a strong mathematical algorithm allows prover to convince a verifier that certain information is true without knowing the private data. So that is the main goal of the zero knowledge proof. So there are two types, the interactive and non-interactive. We'll be studying about this in the upcoming slides. So next is the properties of zero knowledge proofs. So completeness, soundness, and zero knowledge. So completeness is nothing but if the prover is honest and the statement is true, the verifier will always accept it. So next is the soundness. Soundness is nothing but if prover is something called lying, they can convince the verifier that is called soundness. So zero knowledge is nothing but no additional information is really revealed to the verifier beyond the fact the statement is true. But okay. So next is the type of zero knowledge proof. There are two types, which is the interactive and non-interactive, and the third one is the succinctive. So I can't pronounce it well properly. Sorry for that. So first, I'll be talking about the interactive and non-interactive first. So what is interactive basically? It's involves several rounds of communications. Okay. So example, if you take an interviewer is interviewing us. So that is an example of the interactive. So non-interactive is nothing but it's a only message sent. Only one message is sent using a shared random string. Only one message is sent. Okay. So what is the succinct zero knowledge proof? A compact proof that can be verified quickly. Ideal for the blockchain and digital systems that we'll be studying later. The blockchain use cases and all. So now I'll be telling you about the proof of the succinct. It is short digital signature we will usually sign in some when we go into apps like these stock market apps, we digitally sign in that in our gadgets. So that confirms the validity instant sending pages of the evidence of that. So this is a small example, succinct zero knowledge proof. So digital identity verification overview. So what is this actually? So this verification ensures that the person only online is the one who they claim it is. So like the opposite side, if they want to prove it's them only, how do you prove? Through the digital identity verification. So normally this involves personal information like Aadhaar, passport number, or email. But this causes like privacy risk since the data cannot be misused or stolen. So for this zero knowledge is solved. This verifying identity without revealing our private or personal details. That's why we are using this zero knowledge proof. Okay. So example, if you take sharing your entire Aadhaar card to only prove that you are a citizen. So that's wrong, right? You can't just share our whole data to us now. So instead, you can just small verification of that. We can use this digital identity. Okay. So next is the challenges. What and all challenges we faced in this digital identity verification. So first is the protecting privacy. Next is avoiding the centralized database. Third is making the process convenient for users. Okay. So first one, protecting privacy while confirming the accuracy. Like the accuracy is that they're a point there, it's them only, just to know that they are the accuracy. Next, avoiding centralized database that can be hacked. So to do not be hacked, they make a centralized database so that they'll be well safe and private and secure. So next is the making the process convenient. So if it is convenient for the users only, they'll be able to send their verification, or let them prove themselves, right? So that's why they usually make it very convenient for the users. Digital identity verification. So there are some of the steps, which is the step one: prover randomly chooses a question and sends the answers to the verifier. That's step one. Two, verifier selects another question from the set as a challenge. Step three, prover calculates the returns the answers to the challenge. The verifier uses the response to verify the provers access the information. Repeat the action until the verifier is satisfied with the answer. These are some steps that involves the proof. So next is how enhance the privacy in identify the verification. So basically this enables selective disclosures, meaning users reveal only what is necessary. What is necessary to that is only being shared to the identity verification. So you can prove facts like age or citizenship without sharing the actual values. And also this approaches reduces like risks of identity of theft and also data breaches, by the way. So for example, you can take, if you want to prove you are from India without disclosing your full address or your ID number. So for that, this ID verification would be really helpful, right? So use case age verification, just forget about that person. I just took it from just the internet. So one of the use cases is this age verification. So you would have seen that this age verification is being done in every apps we use or any other platform we go. This age verification is very much important. So one common use case is verifying age. So we can prove if they are above 18 or 21 without revealing their actual birth date, right? So this protects personal information and simplifies legal compliance of for online services. Example, if you want to buy bread or something from online, so instead of uploading all your ID, all your personal details, instead just simply say I'm above 18, above 21, above some age respectively. So just specifying a little information, not by just giving all your information in order to like just grab all your information and you get stuff from something like that. Just stay safe. So use case, another use case is access control in digital platforms. So these is also an, oh my god, a secure access control in online systems. So in online systems we use the digital platform. This allows users to prove that they have permission to access a resource without showing their full identity. Like without showing a full identity, we need to show that who we are. So this creates a privacy preserving login system so that we don't share all our privacy things, right? So there are five use cases. The first one is the age verification. Second one is the access control use case. So there are some other five use cases. Now we'll be studying upcoming thing. I'll be showing. So example for this access control, you log into a platform, any platform in online, and you prove you are a premium member. So if you want to prove a premium, example, you take YouTube. So you take YouTube, and there is this subscription called as what do you say? Subscribe. You become a member of the channel. So in order to prove that you're a member of the channel, even if you leave out of the site, even if you delete the app, whatever you do, but your access of the username or the email should not be in that. So in order to be premium member or the member from the YouTube particular channel, so for that you just give small amount of details so that it will not be shared to the other person. Blockchains and knowledge proofs. So blockchain is a system like Bitcoin or Ethereum are public, which means transactions are visible to everyone. So everyone will be able to view your transactions like your Google Pay, something like that. So this zero knowledge proof enhance blockchain by allowing verifications of transactions without revealing transaction details like your name, your phone number, your UPI ID, like through which you transact, or your any other information. So zero knowledge rolls up improve scalability and privacy together. So mainly the privacy is matter in all of our information. So example, you use a cash. So you can prove transaction if you want to prove your transaction is valid without revealing who sent or received the money. Without knowing which from which phone I sent or to whom I sent, without that, how do I prove? For that, this blockchain will be really helpful. This blockchain is also a major impact in the zero knowledge proof. So next is the examples of zero protocols. So the ZK snacks are efficient zero knowledge proofs with succinct verification times. They are also transparent, scalable, do not rely on trusted setups. So basically, there are three major types of protocols. One is the ZK snacks, which is efficient, fast, and but need a trusted setup. You need a trusted setup for that so that instead it doesn't get mismatch or some kind of mismatch happens. So next one is the ZK Starks, which is more transparent and scalable. Okay. So next one is the bulletproof. Bulletproofs are also do not need trusted setups like these snacks or these starks. You just need an ideal confidential transaction for it. That's enough for the bulletproof. So these are the example of these ZKP protocols. So next is the advantages of using these kind of protocols for digital identity. So some of these are simplicity, security, time saver, privacy, and safety. So why do we mainly use this is for the privacy and user control over personal data. So basically, you don't need to your personal information or private data shouldn't be shared to everyone or to anyone so that they misuse it. So that in order they misuse the data so that we don't feel non good. So reduce the risk of identity theft and data breaches. So nowadays these AIs are getting very getting trend nowadays. So to be careful of our identity to not be theft or the data breaches. So that is why we use this zero knowledge proof. Enhance compliance with privacy regulations like GDPR. So GDPR, so enhanced compliance is very much important because global standards for this interoperability are still evolving. So next is the limitations and challenges of this ZK pieces. So some of the limitations are computational complexity and can impact the performance. Implementation requires specialized cryptographic expertise. Standardization like interoperability remains ongoing concern. So one of the major impact for this is the computation. Its complexity also it's very much cost. So you need more expertise person to deal with this. Also, it needs a cryptographic expertise. So you don't get these experts in nowadays in generation. Most of them use AI and then just do kind of stuff. So these are three limitations and challenges of the KPs I found out. So next is the current implementation platforms. Project like Zcash utilizes Zcash snarks for private cryptocurrency transactions. Identity platforms such as Civic and Uport incorporate ZKPs for verified identities. Ongoing research aims to improve usability and scalability of ZKPs. So for this project like Zcash and Zcash, they use it mostly for private transactions. Then Civic and Uport mainly used for security identity systems. So it's for verifying the identities. So next is the research platforms where they continue to make the systems more efficient and user friendly so that people can use it easily. So future trends in zero knowledge proof. So what will be the future of the zero knowledge? Will it be more helpful or will it go down? What will happen? We don't know. But then what I found out why I research is something. These are advanced focusing on making ZKPs more efficient, easier to implement. Integration with integration with decentralized identity framework is expected to grow. Broader adoption will likely influence privacy standard across industries. What expect on layer going forward? So future will be faster, easier to use, integrated with decentralized identity. Yeah, might be there are many things. So these will help making the future more uh, shape up the future and the privacy standards or the privacy, healthcare, social media, everyone will use it. Soon we might log into any website proving I am verified person and healthcare, no password, no data leaks. So I guess I personally feel zero knowledge proof should be a main thing in future because nowadays AI is being very crucial and capturing many faces, and many cases are going on because of this AI. So I guess zero knowledge proof is very much important in upcoming generation. I guess now only if they implement will be really good for people to stop those things. So regulatory ethical consideration, privacy preserving proofs align with emerging data protection laws. Ethical use of ZKPs require transparency and user consent. Policymakers are exploring frameworks to support privacy enhancing technologies. So ZKPs mostly complies privacy laws like GDPR, and before we saw about GDPR. So ethical use of require transparency, consent to fairness. It should be fair around every people, right? So policymakers, yeah, they are also creating framework to support privacy preserving technologies. So example, when banks use ZKPs and KYC, the KYC, the consideration they form, they ask no for like for I use stock market platform. So in that they asked about the KYC details and all. So they didn't ask many of the details, but then they asked. So it should be private, right? So they must explain how clearly the proof protect the customer data. Should be protected so that it doesn't goes to another hand. So implementing ZKPs in real-world systems, successful deployment involves balancing security, privacy, usability. So if you want to deploy the ZKPs, there should be a balanced security, privacy, usability, so that it will be a user convenient platform for user to use it. Developers must consider computationally resources and user experience. Collaboration across cryptography, legal industry is vital. So developers should be having a consideration of the people so that they can use it easily. So example, if you take a fintech company, so in that ZKPs are identities check, but also ensure that systems run smoothly for the customer so that they don't face any kind of problems. Case study, privacy preserving KYC solutions. So previously talk about the KYC. KYC is where, so I'll just tell you a small description of what is KYC. So basically this KYC is something but an information about yourself, that you are the person using it and you're the person uh, that for the transactions and all you do it on your own. So it's a details about where they ask your Aadhaar card or PAN card and such details. Everything is shared actually. So but then it's very safe according to me. I don't know how much safe is it. So it's slightly safe, I guess. So financially, institution utilize ZKPs to verify customer identity without sharing sensitive data. That's what it's share market and all. They use these KYC details so that, but then I don't know how far it's very safe. This approaches reduces onboarding times and enhance data security. ZKB based KYC fosters trust and compliance in financial service. So the bank only, so for example, if you take a bank, they only receive proof that customer has a valid ID or not. The ID number itself is not required. So financially, all financially, they guess KYC is very much important. So now I've come to the conclusion. Even I don't know how quickly I just came to the conclusion. So it's a technology matures widespread adoption in digital identity management is anticipated. Ongoing research aims to improve efficiency, scalability, and user experience. Embracing ZKP can fundamentally transform how privacy and security are handled online. So to conclude this presentation, ZKP. So I feel ZKP is very much needed cryptographic algorithm in nowadays. So it's actually it should be implemented as quick as possible. I guess many of them are using it. The ZKP. Actually, my father is also using the ZKP protocol, cryptographic protocol. So before choosing this topic, I asked my father about what is this about this ZKP. So it's actually an easy topic, but then what is the major thing about this ZKP I needed to know. So that's why I got to know about this. But then I really thank you, sir, Nityanand sir. I hope you see this video, and actually I'm not doing this basically for marks, but then I like exploring things and researching things. So that's what I got to know about this zero knowledge protocol. So I guess you would hope this like this video, and so this is basically not a YouTube channel. I could ask for like, subscribe, those kind of things. So I hope you see this video and give a good grade mark for me. And thank you so much, sir. So it's around 12:30 a.m. at night. So I'll be uploading it as soon as possible so that I'll not be in town. I guess might be because for Diwali I'll be going out. And actually, happy Diwali, sir. And thank you, sir. Love you, sir.